Welcome to Introduction Lesson 1, Video 3, and we're going to talk about the notation, some specific notation on sets. So I'm going to have a set here. I'm going to call it set A, and I'm simply going to have it have 1, 2, and 3 as its elements, and then, of course, the cardinality of set A is 3, because it's got 3 elements. Well, how can we note if an element is a member of a set? Well, there's a cool way to do it in math. For example, I'm going to take the number 2, and we can see the number 2 belongs to set A. And so to denote that in mathematics, we would say 2, and then we draw this kind of funny shaped E. It's more like the epsilon in ancient Greek alphabet. 2 E A, and that says that 2 is a element, E for element, in set A. And we can also say the same for 3. Well, we say that 3 belongs in A, so 3 is an element in set A. Well, what about 4? Well, we can see that there's no 4 in set A, so we would say that 4 is not an element of A. And that's how we denote when objects are elements in a set. Another thing that math wants to do is math wants to establish relationships between numbers and relationships between sets. So I'm going to create 2 sets here. I'm going to create a new set of A, and I'm going to have it have 1, 2, and 3. I guess I can use the same one. And I'm going to create set B. And set B is going to have 1, 2, 3, 4, and 5. And now we want to establish the relationship between A and B. Notice that all the elements in A are in B. And so in math, we say A is a subset of B. And how we note that is we say that A is a subset of B. And this looks a lot like this C, and this vinculum looks a lot like a less than or equal to B, doesn't it? And so we say that A is a subset of B. Well, now let's look at B in terms of A. Well, notice that B has a 4 and a 5, and set A does not have that. So we would say that B is not a subset of A. B is not a subset of A. Now let's look at 2 more. So that's subset, and let's look at 2 more sets. I'm going to create set C, and I'm going to create set D. And set C is going to have 1, 2, 3, and 4. And set D is going to have 1, 2, 3, and 4. And so there's another thing that's called a proper subset. And a proper subset means that there are elements in one set that are not in the other. So, for example, we have here that C is a subset of D, that all of the elements in set C are in set D. Set C's got a 1, set D's got a 1, set C's got a 2, set D's got a 2, so on. And so we can say that C is a subset of D. But we cannot say that C is a proper subset of D. And a proper subset is simply that C looking notation. And why? Because all the elements of D are in C. If you look up here with A and B, we can see that there are some elements of B that are not in A. And so we would say that A is not only a subset of B, again, think of this as a less than or equal sign, And we can also say that A is a proper subset of B, and you can think about this as simply a less sign. And we can say that it is proper subset because there are certain elements of B that are in A. Well, I believe that's everything that you need.